In this tutorial, we're going to talk about sketch the graph of an exponential function of the form y equal to a to the power x, where the base a is greater than 0. Now, we have already worked on some discussions in the previous tutorial. Now here, we're going to solve this exercise. On the same axes, sketch the graph of these three exponential functions. The first one, y equal to 3 to the power x, and the second one, y equal to 2 to the power x, and here y equal to 1.5 to the power x. Now, for every single one, they come in the same form, y equal to a to the power x. And we have discussed this exponential function before. Now, in this exercise, we're going to go ahead and sketch all three of them. For the first one, y equal to 3 to the power x, here are our particular points. Now, for the first one, when x was equal to minus 3, y was equal to 0.03, and so on for the other points. We're substituting the value of x as given, and we solve it to find the value of y. Now I'm going to show you how we did that. For the first one, for x equal to minus 3, y equal to 3 to the power minus 3. Now we're going to use the reciprocal of this, so it's going to be in the form of y equal to 1 over 3 to the power 3, which is 1 over 27. Now, if you divide 1 by 27, the accurate answer is 0.037, but you can round it up and write it as 0.04 or 0.03. It doesn't matter as long as you sketch the graph correctly. Now, we did the same exact thing for the other points, and we found our particular points. Now for the second one, we have already solved this example actually in the previous video where we discussed y equal to 2 to the power x. Now for the final one, y equal to 1.5 to the power x, we also solved this and found our particular points. Now the next step is to plot these points. As you can see here, we used the scale up to 29 since for y equal to 3 to the power x, we had a value of y equal to 27, which is basically why we used a higher scale. Now for the first point, it's going to be right here. Also, the second point a bit higher at y equal to 0.1, third point even a bit higher at y equal to 0.3. Now here we have our common point between all exponential graphs and all exponential curves where it intersects the vertical axis at 1, and here we have our point when x is equal to 2, y is equal to 9, and finally when x is equal to 3, y is equal to 27 up here. Now the following step is to go ahead and connect all of these points that we have just plotted in order to form the curve of the equation y equal to 3 to the power x. Now I have connected them for you. You can notice straight ahead the horizontal axis acting as a horizontal asymptote. The curve doesn't intersect with it, but it is as close as possible. Now here we have plotted the curve for the first one, the first equation, y equal to 3 to the power x. Now we're going to do the same exact thing for y equal to 2 to the power x using the particular points that we have solved earlier. Of course, we do not have the same points since our base a is equal to 2 this time and not equal to 3. And we're going to also do the same exact thing for our final curve for this exercise, y equal to 1.5 to the power x. Now, I'm going to zoom in a little bit here. When x was equal to 3, y was equal to 3.4. So basically, the higher ends of these curves does not matter. Now, let's go ahead and move forward to compare all three curves, the first, second, and the third one, each one having its own equation, 3x, 2x, and 1.5x. Now here, let us go ahead and compare. We can notice that for all three graphs, y is equal to 1, x is equal to 0. And this is basically one of the rules of the indices that we have discussed earlier, and that would be we have a to the power 0, it is equal to 1. Now moving on, discuss something else. We can notice one thing. When x is greater than 0, which is basically on the right side of the y-axis, you can notice that for every value of x, we had this particular order of the curves. We had 0.3 to the power x greater than 2 to the power x greater than 1.5 to the power x. Notice this order. But if you go ahead to the other side of the graph, on the left side of the y-axis, I'm actually going to zoom in a little bit for you. You're going to notice that the same order is now switched. Let's go ahead and zoom into that part of the graph to notice that this particular order is now the complete opposite. Actually, we're going to have 3 to the power x from the bottom now, 2 to the power x is going to stay in the middle, and 1.5 to the power x is actually on top. So this is basically one of the properties of the exponential functions and the exponential graphs. And that would be the end of the comparison of all three curves.